Hey guys, this is a video about the first unit we did called data. This is just a quick summary video. So if you're having trouble with any of these topics, you can go back to the content and find them, and then there's some more detailed videos in the content. So everything we did from data, it was kind of separated into two sections. We had one variable data and we had two variable data. In one variable data, that's where you're just looking at one thing. Like maybe you're comparing different colors or ages of people or shoe sizes. And you want to like figure out how to represent and analyze and compare the data. So you can use different tools to do that. We learned about box plots. We talked briefly about circle graphs, bar graphs, and histograms and things like that. And measures of central tendency like mean, median, and mode, and range. So I'm just going to go over these really quickly. So a box plot is something that you can use to represent one variable data. So let's say we collected a bunch of different ages of people. So we have a 3-year-old, a 5-year-old, 7-year-old, 8-year-old, 9-year-old, 2 12-year-olds, and a 20-year-old. So your first step is to put the data in order from smallest to biggest. Always start with that step first. And then we're going to collect these 5 pieces of information. What is the minimum? What's the smallest number? 3. What is the maximum, the biggest number? 20. Then the next one I like to go to is Q2. That number is actually also called the median. It is the middle number. So what is the middle number? So let's just see. Looks like we have 2 middle numbers in this case. So 8 and 9 are both the middle numbers in our data set. So we have to pick the middle of the middle, which is kind of like what the mean is. The mean is the average number. So that's like if we add 8 and 9 together and divide it by 2, that will give us our average, which is our median in this case. So that is going to be 8.5. So that's also the median of our data, 8.5. Okay, so once we do that, we know that 8.5 is actually our Q2. Then we have to find Q1 and Q3. So when we do that, we look at this section of our data, and we have to find the middle of it, and we look at this section of our data, and we need to find the middle of that. Okay, so the middle of this is going to be right in between 5 and 7. So it's going to be 6 will be Q1. And then the middle of this is going to be right here, which is just going to be 12. So box plots are kind of funny. When you have an actual middle number, you don't use that when you're finding Q1 and Q3. So for example, if my data set was like 1, 3, 5, 6, 10, and this is my middle number, now I'm not going to use that. So when I go to find Q1 and Q3, I'm going to find the middle of those data sets. Whereas if my middle number, so I don't end up using my middle number in a box plot, like when I'm doing Q1 to Q3. So, but I can include 8 and 9 in this data set because that's not my middle number. Okay, cool. So we found all the information we need to make a box plot. So then, I'm just gonna make a quick box plot here. What I like to do next is just make a little scale for myself, going from at least 3 to 20. And I need to go up in equal increments. So maybe I'll just go by 1. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm just going to label every other one. Although that turned out kind of weird because I ended with 20. Let's just do that. Just because I didn't have room to fit all the numbers in. But anyways, there's my scale. And then I'm just going to put a vertical line at all of these numbers. So 3, 20, 6, 8.5, 12. And around Q1, Q2, and Q3, I'm going to enclose them in a box. And then I'm just going to attach a little whisker to my min and my max. And that's what a box plot looks like. So that's your minimum, that's your Q1, that's Q2, that's Q3, and that's your maximum. It's also important to know that 25% of the data is in each section. So 25% of the data is right there. 25% is here. 25% is in here. And 25% is here. They're all split into equal quarters. That's the idea of a box plot. So even though sections look bigger than the other, this contains 25% of the data, as well as this, and this, and this. They each contain 25% of the data. Okay, that's a box plot. Measures of central tendency are these things here. Range is our maximum minus our minimum. So 20 minus 3 would be 17. It's like the span of our data. Mode is the number that occurs the most. So in this case, it's 12. There can be more than one mode, or there could be no mode at all. And the mean, you just add up all these numbers and divide by how many numbers you have. So you would just do 3 plus 5 plus 7 plus 8 plus 9 plus 12 plus 12 plus 20. Once you do that, you divide by 1, 2, 3, 4, 5, 6, 7, 8. Do we have 8 numbers? Yeah. Divide by 8. And I don't have a calculator, so I'm actually not going to do that. Sorry. But that's what you would do. Okay. These are some other ways that you can represent data using one variable. We hardly talked about it at all in the course, but hopefully you talked about it in grade 7 and 8. So circle graphs are where you take your data and you kind of put it into percentages, and you would just show like, 25% of the people like cats, and half of the people in this class like dogs, and maybe like 1/8 of the people like horses, and another 1/8 of the people like zebras or whatever. So it's where you just take the data and you section it off in a circle. Bar graphs are, say you did like, how many people are born in January? 1 person. Oh, how many people are born in February? 3 people. It's like where you just use bars to represent frequency of things. And then a histogram is similar to a bar graph, except it's all quantitative stuff. So down here would be also something that has numbers, like maybe ages. And usually you would do it in a range. Like maybe this is like the 0 to 3-year-olds, and this is the 4 to 6-year-olds. Or 7, I guess. I have to keep the same range. And then it would like go something like this. Okay, so that's our 1 variable data. 2 variable data, we mostly talked about scatter plots. So an example of a scatter plot is this. So we can compare 2 things. I can compare time and distance, or age and height, or money and temperature, I don't know. So you can compare 2 things at a time, and we can graph it like so. We can add something that's called a line of best fit to our data, which is a line that is as close to as many of the points as possible. We're looking to minimize the distance from the line to like all of the points, this distance here. So we would never draw a line, we would never draw a line that went like connected dots. We never want to do that. We always want to do a line that just kind of fits the trend of our data. So I can see that this situation would actually represent something called positive correlation, which means as time increases, distance increases. So both variables are increasing. So in a positive correlation graph, all of our points are going up to the right. In a negative correlation, that's where the thing on the bottom is still going up, but the thing on this side is actually going down. So it would result in a graph that's going down to the right instead of up to the right. And then we can also have things that have no correlation, and they're just a scattering of dots, in which case you can't really draw a line of best fit because, I mean, you could draw a line like this. You could draw a line like this. You could draw a line like this. Like, there's no way to draw the line. Could look like anything. So there's no relationship between the two variables. I think we talked about things like having an R value, and that just tells you how correlated the two variables are. So if you had something that looked like this one, that's very close together. So maybe that would have an R value of like 0.98. So an R value of 1 means they have a perfect relationship. Like, you could make an equation that would fit every point on the graph. So that would be like completely on the line, like that. It doesn't necessarily have to be straight. It could be a relationship that even looks like this. That could be completely, that have still an R value of 1. So like this R value could be 0. So you're going to have an R value between 0 and 1 means the points are very close to the line. You can also use something called extrapolation and interpolation. That's when we just try to like estimate stuff within our graph and outside of our graph. So if I wanted to know how far did someone travel in 25 minutes? Well, I'd have to kind of extend my graph and estimate, well, at 25 minutes, if I were to go up, I think my line would be here. So then I'll just go over to the graph. I'm estimating 50 meters. So you can use your line of best fit to get some points. Or maybe I want to know after 2 minutes. So I'll just go, oh, right here. Oh, maybe like 12. So you can use your graph to get information. And you can go the other way, like how much time did it take to drive 30 meters? Oh, let's see. Oh, right here, maybe 14 minutes. And that's interpolation and extrapolation. Okay, I think those were the main concepts we did from the data unit, but you can head back into the unit if you're not sure about any of these terms.